Welcome to Frequency Matters, the RF and microwave update. I'm Pat Hindle, and I'm here with my co-host Gary Lerude. It's our last episode of the year, and we'll be covering our December 5G and IoT issue.
Right.
We used to do this as a supplement, but now it will be a full issue every year in December.
Right, given the trend in 5G and IoT.
Yep, they're so big that definitely an issue, maybe even two issues will be called for next time. So the cover story is written by James Kimmery of National Instruments, and he talks about 5G, are we ready for it yet? So he covers the technology and the state of the standardization that's going on. So it's a nice wrap-up of all the activities that are going on in the 5G area. What else do we have for technical features?
Well, we have three interesting tech features. The first one is, will the millimeter wave link work, by Rohde and Schwartz. And it's a really interesting investigation of the actual link budget they use the Verizon pre-5G 28 gigahertz fixed wireless access service as a model that they investigate. And it's really interesting because I haven't seen that level of detail in terms of analyzing the link budget. So that's good. We have a Keysight article on, are you ready to test for 5G data rates? And here they're looking at the challenges associated with more than 5 gigabit per second data rates, operating at millimeter wave, and particularly with beamforming. So that's a key one. And then switching to the IoT side, we have from the AWR group at National Instruments an article on narrowband IoT. And they analyze what is narrowband IoT, how does it coexist with GSM as well as LTE, and then how can you use a system simulator like their VSS to actually analyze the end-to-end performance of an IoT network.
Yeah, this is a great issue. I think it's one of my favorites for the year.
So how about product features?
So for products, we had some exciting new ones, and two of them were industry firsts. So we had Qorvo announcing the first 5G front-end module, and it operates from 3.3 to 3.8 gigahertz and supports up to a whopping 400 megahertz of bandwidth. So it could put some serious capacity throughput through the phone. And then we also had Anokiwave introducing the first 256-element reconfigurable phased array for 28 gigahertz 5G fixed wireless access. And they've done a 64-element version, but this is 256-element, really gives the power and all the other performance requirements that people are looking for. And to my knowledge, this is the first one that really meets the operator's requirements for it.
Yeah, that's really impressive.
Then we also had Anritsu introducing the high-performance 5G analyzer, and theirs goes to 44.5 gigahertz and has 1 gigahertz of bandwidth. Finally, we had CST, and they talk about CST Studio 2018 and all its new features. So quite a lineup there for products.
So tagging on to some of the 5G activity in the news, we have a record data rate for 5G, yet another one, and maybe by the time our viewers watch this, it may be out of date. But Huawei and NTT Docomo demonstrated in Tokyo a 28 gigahertz link with 4.52 gigabit per second downlink, and they achieved 1.55 gigabit per second uplink. And it was a clear line of sight, about 1.2 kilometers, so it was a best case scenario. They actually mounted the base station about 340 meters high on the Tokyo Skytree, which is a broadcast tower and observation deck. And then the receiver, the user equipment, was down on the roof of a shopping center. So quite an impressive result, and it shows the potential capabilities of 5G.
Yeah, it's a good distance for millimeter wave.
Right.
And also in 5G news, Verizon announced that they awarded the networking equipment contract to Ericsson.
Right.
And this is for their pre-5G standard fixed wireless access at 28 gigahertz. So we all know that they've been doing trials this year in several cities in the U.S., and they'll be rolling this out in the second half of 2018. So here we go. 5G will be real next year.
Yeah, I think if any of our viewers are in Sacramento, I think that's the first city that's going to get some of this.
They'll have some good fixed wireless access, high speed.
Right.
So I don't know, I'm not really in the mood for the holiday spirit yet.
Yeah.
Have you made your Christmas list or anything like that?
No, I'm way behind. I need to do that. I was thinking maybe after this program I could spend some time doing that.
Well, maybe we can fix that. Now that's better.
Yeah.
I'm in the Christmas spirit.
I am too.
So we're back with our annual holiday episode, Gary and I. And this year we thought we'd do something a little bit different. We thought we'd make a list of the best products for 2017 by putting them on our Christmas list.
Right.
So we'll write Santa a big list of our favorite products for the year.
So what's on your list?
So I was in a test and measurement and software mood when I wrote my list. And my first product that's on my list is Rohde & Schwartz OTA power measurement solution that measures the transmit power over the air interface. The solution enables working in the development and production environment to calibrate the output power of the antenna on the DUT and test the DUT beamforming function. It operates from 27.5 to 75 gigahertz.
Wow.
So it covers the millimeter wave bands being used for 5G and wireless gigabit applications. And my second one is National Instruments and AT&T's millimeter wave channel sounder for 5G that is nicknamed the Porcupine.
Oh, I remember that.
The system measures the channel from a 360-degree perspective in real time, utilizing a unique antenna design that deploys 16 quad horn antennas, yielding 64 elements configured in a 360-degree semisphere, where the data from each quill is captured and processed in real time. And then the next was Anritsu's ultra-portable handheld millimeter wave spectrum analyzer that provides continuous coverage from 9 kilohertz all the way up to 110 gigahertz and is well suited for applications such as 5G, 802.11ad, and satellite communications and automotive radar. And it can even be attached to a commercial drone because it's so small and light.
Wow.
Next was Keysight's broadband millimeter wave network analyzer that delivers very high quality system accuracy up to 120 gigahertz. It produces metrology-grade results that enables developers to confidently characterize their millimeter wave designs with magnitude stability of less than 0.15 dB and phase accuracy of less than 0.15 degrees over a 25 period, so extremely accurate. Next was Copper Mountain's one-port VNA, which is the first 18 gigahertz one-port VNA that can connect directly to a DUT. So it improves the accuracy by eliminating the RF cable connections. This is also small enough to fly in the drone, so I'm excited to be able to hook one up to my drone and see how it works.
Yeah, definitely.
Next was SignalHound's real-time RF spectrum analyzer and recorder. That is a 9 kilohertz to 6 gigahertz spectrum analyzer and RF recorder with instantaneous bandwidth of 27 megahertz and sweep speeds of 24 gigahertz per second. And believe it or not, it's under $3,000, so I might actually be able to afford one. Then we had Wireless Telecom Group's Booten Power Meter that provides video bandwidth of 195 megahertz and rise times of 93 nanoseconds. Plus, it delivers real-time power processing of 100,000 measurements per second. It combines this performance with automatic pulse measurements, CCDF, and crest factor statistical analysis, multi-channel capabilities, and documentation tools. So quite the package.
Yeah, I remember being impressed by that when I first heard about it.
And then my software candidates on my list are ANSYS 3D Layout with 3D encrypted components that can revolutionize design and business processes by enabling designers to share the data with IP protection and assemble large 3D models to predict system time and frequency domain performance.
That's a really cool concept.
And I also like NIAWR's ANSYS, that is a cloud-based software as a service automated antenna design, synthesis, and optimization tool. It takes antenna engineering requirements as an input and outputs antenna designs. The ANSYS was designed for antenna engineers who are experienced and also those who are novices like myself. And finally, CST's Studio Suite 2018, and it offers a collection of new features from designing, managing, and simulating complex devices and systems. The tools increase the versatility of CST's Studio Suite for modeling and simulating complex systems and strengthens workflows for applications such as antenna placement and installed performance, co-site interference mitigation, and SAR and exposure analysis. So that's my list.
Wow.
How about you?
Well, I'm more on the component semiconductor side, and I pretty much have done these in alphabetical order. Starting with analog devices, they've developed a 24 gigahertz radar sensor that includes the transmit and receive antennas and the RF to baseband signal chain, including the DSP. They call it DemoRad, and the sensor has 2 transmit and 4 receive channels, which increases the angular resolution they can get, as well as enabling MIMO operation. The DemoRad connects to a PC, and that has a suite of radar algorithms. Then moving to Anokiwave, you mentioned them earlier in the show. They, working with Ball Aerospace, introduced this 28 gigahertz, 256 element reconfigurable active antenna. And it uses Anokiwave silicon quad-core IC, and that follows the 64 element unit that they released earlier in the year. And they've also done a 39 gigahertz quad-core IC for that band, also another fixed wireless access band. So it shows that they're really active in going for the fixed wireless access market. My third one is MACOM, and working with Lincoln Laboratory, they've developed a multifunction phased array radar that's based on a tile architecture. And that uses surface mount components and high volume commercial manufacturing processes, so it gets to lower cost. And the radar is a good candidate for air traffic control and weather radar systems. Then Qorvo, and you mentioned this, introduced what they say is the first front-end module for the new radio 3.5 gigahertz band. And the QM19000, as they've named it, integrates the power amplifier, low noise amplifier, a transmit-receive switch, and wideband filter, and it handles up to 400 megahertz of instantaneous bandwidth between 3.3 and 4.2 gigahertz. As the number of MIMO channels increases in wireless infrastructure, the traditional connectors are proving to be too large. Rosenberger, Huber-Suner, and Radial joined forces to develop the Next 10 connector. Shrinking the size by half compared to the prior standard wasn't the only challenge they had to face, though. The connector needs to operate to 20 gigahertz with excellent return loss, and it has to have passive intermodulation of minus 166 dBc or better.
Yeah, that was a cover feature for a March supplement.
It was. And then after years of predictions, the growth in data consumption is finally making small cells a reality. And Skyworks is meeting the need for high-efficiency power amplifiers for small cells with a complete family of PAs that cover from 700 megahertz to 6 gigahertz, which includes the new Citizens Broadband Radio service at around 3.5 gigahertz and the band for license-assisted access, which is at the 5 to 5.9 gigahertz range. And because power consumption in small cells is critical, Skyworks designed this family to deliver between 30 and 40% power added efficiency. On the high power side, Wolfspeed introduced a family of 28-volt GaN power transistors, which are based on the company's quarter-micron GaN process, and GaN on silicon carbide, of course. And comparing it to the prior generation, which was 0.4 micron, the new transistors have higher gain, higher efficiency, and they extend the frequency coverage to 8 gigahertz. They also designed these to have the same package footprint as the prior generation, so they can be drop-in replacements in some applications. Xilinx extended its Zinc UltraScale Plus RF SoC family, which is a system-on-a-chip architecture that integrates the RF data converters with the soft decision forward error correction blocks, high-performance programmable logic, and an ARM multiprocessing system. And this level of integration, which they've done in a 16-nanometer SoC, reduces board footprint and power consumption by 50 to 75%. The RF SoC is well suited for 5G wireless, cable remote physical layer, and radar applications. So everything I've mentioned so far has been a specific product or a family focused on a specific application. However, the candy store of RF microwave, from passive to active components to complete test systems, has got to be mini circuits.
I agree.
I'd love to have a shopping basket and an hour in the company's warehouse, then some time to see what type of a system I can build and test. So that's my list.
Wow, so I think we put together quite the array of products there, and those of you who are watching, keep that in mind for giving us ideas for gifts for us.
That's right, and if we got all those things, I don't think we'd have room in the house to store it all. So we'll have to talk to Carl about expanding the office.
And I'd like to wish everybody from the Microwave Journal family happy holidays.
Yes, and we want to thank you, our viewers, for watching and letting us appear on your monitors every couple of weeks. This is great fun that Pat and I have, and we couldn't do it without your support. So as we look to 2018, we hope that you, your families, and the microwave industry as a whole have a very prosperous year. How about some eggnog?
I'll do it.